You thought you were programming mostly in high level languages and with C and C++, but it looks like a lot of it's based on what the assembly is already capable of. So your compiler is only doing a little bit of work when it's converting your code into C or C assembly from C. Edward, you meant C? Yeah, that totally makes sense. All right, here you go. So let's get back to this real quick. So here's how the chain kind of works. So you've got your source code, like your C code or your Rust, and then it goes into a assembly, and then it goes into then you need to link it to the linker, and the linker is going to link with the operating systems, like APIs and kernel APIs, basically. Kernel, there we go, kernel, which makes it run for that OS and target and CPU. So that means it can run on your system that you built it for. So the stages go like this. You do this, and then you compile to assembly. But when you compile to assembly, you need to make sure you're targeting the right kind of assembly, because there's a different kind of assembly based on your processor, whether you're doing a RISC, like RISC or ARM, or like an x86, right? So there's going to be different instruction sets. All right, here we go, you guys. Now we're done with the beginning. Let's see if there's any time left for the assembly. Okay, so I really wanted to do a for loop. That was like the main thing that I wanted to do today, was a for loop. Just getting a for loop to go. So you can do that, but in order, I believe there's like a bunch of go-tos that you can do. So let's go ahead. I wonder, can you comment out? Yeah, we can do comments like this. So that's actually useful. Here we go. Comment out that. So that was our multiplication, but we don't need to deal with that right now. We also don't need this. Here we go. All right. Let's see if we can finish out this here. Cleaning up some code. So we're working on assembly now. We're actually doing some assembly. The whole point of the stream today was to do the assembly, but we got distracted a little bit earlier. All right, so we've got our X1 register that gets the data for the string. .label is most important, I believe. Okay, so if we want to do a loop, so say, for example, we want to print hello world multiple times, invoke the system call. I wonder if we could do this like loop here, right? And then go to loop here. And then it will infinitely, we got to be careful with this. Isn't this dangerous, what we just did, guys? Label's the most important. It is. Yeah, so here we go. If we build this and it builds, our loop is it going to build. So ./build, and then we say hello.s. And it doesn't build because I don't know how to use, I don't know how to do assembly. So here we go. This is where we need to learn how to do a loop. And I think this is a problem, right? You guys, in computer science, we learn about this. Infinite loops are a problem unless it's a game loop, right? If you've got a render engine and you have a way to escape, but this is an infinite loop if it were to actually compile and work. By the way, for loops in assembly is usually how you would do a while. Yes, a while. We want to do a while loop, so sort of like a continuous loop, but obviously I want to break. I don't want to have an actual infinite loop because that's dangerous, right? We don't want to explode anything. You have a computer condition and then condition to jump to exit the loop, otherwise jump the initial loop. Yes, that's what we want to do, Alexander. Exactly. That's exactly what we want to do. So is it called jump? J-U-M-P? Or like what's the command? Actually, I'm kind of curious. I don't know. Jump loop. Infinite loop. Keep the programming running. Okay. Is it called jump? Is it going to build? Are we going to build it this time? All right. So it doesn't like jump. I'm having issue with jump. Unrecognized instruction. Mnemonic. Okay. How do we do loops? What are you teaching? We are trying to learn how to do a for loop in assembly. And we're guessing right now. We're playing the guessing game. We don't actually know. I don't actually know what the answer is. So that's what we're trying to figure out. We're trying to figure it out. B label. B label. What do you mean by B label? Let's try to compile this. Nope, doesn't like that. Jump maybe? Jump. Oh, nope, not that. Here we go. All right, we're going to figure it out. Assembly is a type of language that if you want to make a project by it would, in your dreams that night, like a nightmare. Yeah. It is just so much to keep in your head because we're just trying to even do a simple for loop here or any kind of loop really. And we're just throwing stuff at the wall. Eventually we'll get it, but also we'll give up and look it up on the internet pretty soon here. We'll get up and look it up. B as in branch. Dot loop here is label. All right, so dot loop here. Okay. Let's see. Yeah, see that like that. There we go. Label. I thought, so not jump. Maybe it's loop. Maybe like that. It's like that. Nope, doesn't like loop. We're gonna figure it out, you guys. We're gonna figure it out. B. Oh, so I have to type it like this. B loop here, or B like that. Something. So B label, branch the label, and then B loop here. Something like that. Well, it gave us a different error. Label. Instead of loop. Okay. Yep. All right. So B, and then maybe something like that. Loop here. No, not like that. All right. JZN is x64 and won't work on ARM. Oh, Edward Martin. Yeah, Martinson. We are currently running on ARM, so we need to make sure that add the colon. Okay. Like that. Maybe like that. Oh, hey. Undefined symbol for the architecture ARM loop here reference. Built. Is it gonna work? Is it? So it compiled, you guys. Does that look correct? Are we correct? Does that look good? The assembler said it did, or the assembler said it looked good. It's like, okay, we got it into machine code now, and it's happy, and it linked it, and it created a binary. I think it's B label. Did we type the word loop? So we've got B, but can we say loop like that? Does that also work? Let's see here. It doesn't like loop, but it likes B. What is B? B is branch for loop forever. B is branch. Oh, someone was saying that earlier, but it didn't click to me because I didn't match it up, you guys. I did not match it up. All right. B for branch is loop forever. All right. So here's the deal. I bet you if I ran this program, it would run forever in an infinite loop and just continuously print hello world. Would it cause my system to crash is what I'm worried about. I'm worried about that. That's what I'm worried about. But you know what? If we put the code here like this, and then we said loop there, it would never reach this point, right? It would never reach because we're invoking a system called exit. Will this still build, you guys? Do you think this will build? And it does. It builds. Okay, cool. We're learning here. We're looking good. We'll just freeze one thread. Do it, Gareth. You're saying do it. Do it. Okay. So we've got a thing that is supposed to be an infinite loop, but my guess is that we're invoking a service to call an exit, and it should never ever reach here, right? It should never reach here, right, guys? Right? This one section here on the screen. It should never, ever reach here. It will not crash. It'll just peg one thread. Is that what you think? You can still break with Control-C. Okay. Here we go, you guys. Yeah, we're going to do it. We're going to run it. This is essentially a branch for an infinite loop, but since I have the code here to exit, I think it's just going to print the first hello world, and then it's going to exit, right? I think that's what's going to happen. But here we go. Just do it. All right, we're going to do it, you guys. Here we go. So /hello world. Hello. Here we go. Boom. See? I knew. I told you I was going to print one. And then you can reset. Yeah. Okay. So let's now let's move this stuff out. And now it should be an infinite loop. It'll peg the thread. It's order of precedence. Yeah. In the case of exiting first, it's going to exit. Try and kind of do a sleep so it can free for a second. Oh, yeah. There's a sleep. Oh, is there? Wait. There's a sleep. Thank you for the likes, you guys. I appreciate it. We should do that. We should do a sleep. Edward, you're brilliant. You are brilliant. Okay. How do we do a sleep? Let's see if we can do a sleep, you guys. Sleep. Is there a way to do sleep? How do you do sleep? How to do sleep in ARM64 ASM assembly. Let's do it. I want nanosleep. There's a nanosleep or RX system called nanosleep. Here we go. How to do it, you guys. Oh, you have to call the operating system for time spec. Is that what you have to do? Not really sure, but it should be a syscall. It is a syscall, you guys. This is a syscall. So we'll have to create another register, and then we'll have to create the duration, and then prepare time spec for sleeping duration 1 second. For example, time spec quad 1 second. Okay, so where's the quad? Here's 1. Then we're setting it to x1 is null for the remainder of the pointer. So LD X1, X0. So we'll need to change these registers is what we'll have to do. Like a sleep for finding IO, file IO, and more. Is it? It contains all the things that interact with the OS. Finding the syscall is the right choice. Okay. So let's try this. Let's copy and paste this. And then I would like to try to sleep before we do the infinite loop. And then we will do the infinite loop, you guys. And that will be the conclusion. Then we'll win. And then we'll be successful at today's stream. And we have done it. We've achieved the goal, you guys. That's the plan. I'm so excited. Okay. So instead of, let's comment this out here really quick. Because we're not going to loop yet. We're not going to do it yet. But we do want to set paste. Paste. Here we go. And then we're going to go here. And then we're going to paste in a sleep statement. So this should sleep for 1 second. Is that what it's saying? But we need to make sure that our registers are, let's capitalize this really quick. Capitalize, please. Thank you. Capitalize. And we're going to capitalize that. And then we want a different register. We want it, like, we'll just like 5, for example. And then we'll do 6. And then what's 8? Why is this 8? Move 8. Oh, to register 8. And then we'll call, is that service call? To sleep. Okay. Service to sleep. And then we will do move X16 and X0 to print. So what this should do is let's build it. Okay, so it didn't like timespec reference start and hello, symbol not found for architecture ARM. Instruction branches unconditionally to a label at a PC relative offset with a hint that is not a subroutine or a call return. Wait, with a hint that this is not a subroutine call or a return. It just goes. So I guess this is like the go-to? Is this like go-to? It basically is go-to. Sleep is a system call. Yeah, it is a system call. And so in order to get access to that system call, we have to do a thing. And I don't know how to do that right now. But you don't have to sleep instructions. You don't have to. Okay. All right. So it would be neat if we could sleep, but it's okay that we're not. So let me double check here. What we're going to, yes. Okay. That makes sense. We just need to know what the syscall is. So hold on, set no paste. Here we go. So is it like a call? And we have to do a system call, right? Go to inserts. So the return changes the stack. Oh, gotcha. Okay. So we're basically we're jumping then in that case. We're just going over to some new code and there's no stack changes because we're not returning back up to a previous context, right? We've got our context, and we're not changing context in that case. But we'll try this sleep thing. Okay, that makes a lot of sense. What we're gonna do is we're going to see if I can get. Here we go. We'll do open. We'll ask the same. We'll ask the same question really quick. Here we go. Copy that really quick. And then I want to add this. Here we go. Bang. And then we'll get that running. And then I want to copy and paste that here into our ARM instruction set. So that way we can have the sleep. And then we'll see if it loops forever. And then we will win. That's the plan, you guys. Then we'll win. That's what we're going to do. So we'll get that instruction really quick. Because we could just, keystroke and brute force it like we were doing earlier. And then we eventually got it, but with help of you guys. Thank you, you guys. With help of you by using branch with B. The B. Who would ever think that B is going to be your go-to or jump? Like who would ever thought that? Edward, once you had to sleep in a loop on C++ because you were using 100% of the CPU? Yep. That's a good way to reduce the CPU usage. Just pause the execution for a little bit. Just call out to the system. Let's see if we got it. All right, here we go. Oh, I recognize this from C. So you need seconds and nanoseconds. A line through here. Let's copy and paste this. This is going to do our sleep. This is our sleep instructions, but we also have some data that we want here. So I'm going to put this in our data section. Here we go. So we're going to have some TS and a quad. So TS is going to be, is this how you do a struct in assembly? This is weird. Because in C, when you want to access the time, the kernel API for time, you can get you need a TV second and TV nanosecond. So I recognize that there, but this is weird. This is actually kind of interesting. This looks scary. It is. It's very scary. TS. So this might be for time spec. Oh, we needed to define this. So we didn't have it defined earlier. That's why. You guys. Okay. This makes a lot of sense. And so this is going to exit. So we don't need this. We're going to call We're going to do the sleep here. So this is the sleep. So let's see if we can grab that. We don't need the data label anymore. Let's get rid of that. All right, here we go. Now we can move down here and let's see. So this is what we need. This will sleep because we've got TS defined here. TS is defined here, right? Dot line 3 TS. I think something like that, right? So it'll be like this, and then we've got a hello string, and then we've got our line number quad. Okay, so we actually don't need this anymore, but I'll just comment this out. So it makes it simpler, you guys. Here we go. And then once we did this, and we'll end stream because we win at life. Bro, that's amazing. You're trying to learn assembly? Crow, the Zota tax master. Yes, that's what we're trying to do. That's what we're trying to do right now. We're currently learning assembly. It's here, you guys. This is the last thing we're going to do. We wanted to do a loop. We got it to compile. We got the loop to compile. It works. We didn't run it because it could be an infinite loop. So what we're going to do is we're going to just be super safe, and we're going to put a sleep in. We're going to put a little sleep in between the loop. And so that's what we're going to do. And I'm already lost. Like, I'm already lost here. But the sleep and see, so we have to, I think what we have to do is put the loop up here. So that will go there. And then we do a B loop. And then this will never be reached because it's a system call to exit. Here we go. And then we want the loop. Okay, so here is where we invoke the system call to print hello world. And so it prints and it loops, and this loops forever. But we need to put the sleep in, and that's right here. So we have to do this, I believe. And I don't think, so we've got our TS there. I think we need different registers. Let's see, increase, no, let's do a capitalization. Let's do capitalization. And then we need different registers because I don't want to have to redo them later. But we do have to, struct time struct null. This is, I'm actually going to kind of see, is this going to build? It does, but it has some problems. Has a few problems. We're going to figure this out. What we want to do is get a for loop. We were able to get it to compile, or well, to assemble to machine code and then link it. And so it worked. We actually created a binary that is compatible. And I didn't run it yet because I was scared. And so I wanted to put a sleep in. But then we got into a difficult situation where we needed to make two system calls. One system call for the sleep and the other system call to print to standard output. And then we loop. And we do that in the loop. And so I've got that on my screen here, but it seems like I need to, oh, right, here we go. I need to get system call, blah, 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 at offset. Here we go, move 16. So I think if we do this, it should work, maybe. I don't know. And then SVC is to invoke the command, the instruction. Are we going to do it, guys? Is it going to work? It still has a problem. Oh, TS, LD illegal. So TS is a problem. It does not like TS, but I had TS here. Did I do it wrong? LD data align TS. So is this maybe I need this separately? Maybe I need it separately. Let's see here. So let's see here. Align 3. What if we got, I think we have to say align 3. I don't think there's a way out of it. And then once we have this, once we get this to work, then we will win. We'll count it as a victory, you guys. That's the plan. Data should be used only once. Okay, thank you, Alexander. Only once with .data. Perfect. Oh, I get it. Oh, this is starting to make sense now. I didn't know you could do this. So you're assigning the TS variable with two quads. You can do that? You can do that in assembly? I didn't know you could do that. So that's basically like a struct in C. I think we say align 8 here. Let's see, try that. See if that makes it better. Nope, doesn't like that. So TS, let's do time spec. So there we go, time spec. And it's quad word. It's a word. Oh, it's still a label. Got it. Okay, totally makes sense. So let's go back to TS. Let's do that. Is that gonna make it better? It says it's not better, but let's see, X0. How do we assign time spec to a register? So how do we do that? So it looks like I don't need to use this equal sign. Like I don't need to use the equal sign. Is that it? Is that what it is? Maybe we don't need to do it that way. Maybe we need to do it a different way. How is it doing it here? And the address holds the equal to the quad. Got it. Got it. We're learning things. We're going to go for it. So here's the deal. We've got this infinite loop here that's really scary. So I'm going to just comment this out. And then we are going to have an infinite loop. And what it does is it infinitely prints hello world. And so what we should see, maybe you should use the brackets in the LDR. Let's try it. Let's try it really quick. Let's do that. Let's do it. So like this, like that, time spec LD0. So we had this, right? Like this was this, load the value into the address. So we're going to load the time spec into X0 like that. LDR. Let's try it. A little bit different. A little bit different. We're making our way. We're making our way there, you guys. Time spec rem null. Nano sleep. Do the sleep. See, that's what we're trying. That's what we're trying to do. But it seems like you guys, it's not. We went a little too far. I'd say we went. I'm not sure. So we're still learning. We're still learning. Oh, you ready, Edward? You ready? Okay. So I disabled the sleep because it's basically like a struct in C, like a struct essentially, just like this. Isn't that cool? I didn't know you could do that. But what we're going to do now is we're just going to run it. So we built it, and here's our loop. And who had ever thought that the letter B would represent a loop, right? To loop back to our label, which is loop here. So this is our loop on the screen, you guys. So this code should loop infinitely, and it will get a whole bunch of hello worlds printing out on the screen. Here we go. All right, so builds. It builds it. All right, here we go. ./hello world. Hello, is it going to see? I think we're going to see a whole bunch of hello worlds on the screen. All right, here we go. We're going to run it. If the stream crashes, you'll know why. Just to let you a little bit of forehead. Here we go. I'm going to press it. Boom. Hello world. Infinite loop. And is it, it's causing, yep. Is everything fine though? Everything seems fine. We're just spinning up a loop. Can I exit? I did. Okay. Control C worked. We did it, you guys. We did it. In assembly, we had a loop that looped forever. Yes, it was infinite. We could probably put a break statement in there on a condition of some sort. I wanted it to sleep so it would print slowly through a system call, but that was just a little too much. That's what you can do it in assembly. And it's so cool because I didn't realize how close assembly was to some higher level languages already. Like already there's like loops, there's if statements in flow control, there's variable assignments, there's patterns you can do with structs. Yeah, it's not allocating memory or something. Yeah, woohoo, we did it. We did it, you guys. Success. I know this is like the silliest possible thing from a computer science perspective. Like we're doing entry level stuff here, but it's exciting. I'm still excited about it because it's a lot of fun. I'm used to higher level languages like C and Rust and Python and JavaScript and Erlang and Kotlin and you name it. There's a whole bunch of different languages out there, but learning assembly kind of teaches you a little bit more about what you're doing in the higher level languages, doesn't it? You guys, it's worth it. That's why learning assembly is worthwhile. We'll continue our assembly adventures. Tomorrow, maybe we'll do like a flow control. We'll do like some if statements, and maybe we can break our loop because right now our loop loops forever. But I'd like to be able to break at some point. Like we got to do a break. We need to be able to do this right here. We have to do this. We need to be able to break, but in some way or sleep at least, right? I think that would be a lot of fun. Do a system call to sleep using our defined time size, our time spec. So that would be something that we would do next time. The for loop, we did it, and it loops forever. Hello world, a whole bunch of hello. We did it, you guys, and it's all running in assembly really fast. We did it.